Welcome, students. Today, we're conducting a deep dive lecture into one of the most powerful tools in all of financial planning. We're not just going to memorize a formula today. We are going to understand the logic that helps both individuals and, yes, massive corporations build their financial futures one single step at a time.
So let's start not with a bunch of numbers, but with a common aspiration. A pretty universal goal, really, saving up a significant amount of money. Could be for retirement, could be for a down payment on a house, or to start a business. That number, $50,000, can feel, well, kind of daunting, right? So how do you take that big, maybe even scary number on the horizon and turn it into small, manageable steps that you can actually take today?
Well, the difference between a dream and a goal is a concrete plan. And in the world of business mathematics, that plan is very often expressed through a formula. It's the roadmap. It's what takes you from saying, I wish I had, to knowing I can achieve this. Okay, so here is the roadmap for our lecture today. We're going to build our understanding methodically. We'll start with the fundamental principle. Then we'll introduce the formula itself. Next, we will deconstruct every single piece of it. We'll see it in action with a real-world retirement example. And finally, we'll see how the very same logic is used in corporate boardrooms for billion-dollar decisions. Before we get to the math, let's establish the fundamental principle of an annuity. It's all about the power of consistent, periodic contributions over time. It's the simple, beautiful idea that small, disciplined, regular contributions, when you give them enough time and the benefit of compounding interest, can grow into something truly substantial. Now, let's introduce the specific instrument we'll be mastering today. This is the tool that allows us to calculate those regular contributions with precision. This is your financial blueprint. And here it is. This is the formula for the periodic payment of what we call an ordinary annuity. Now, I know it might look a little complex, a little intimidating at first, but our goal here is to understand every single component intimately. We're not just memorizing, we're understanding. By the end of this, you'll see every part of this has a clear and logical purpose. Okay, let's dive into this and deconstruct the formula, piece by piece, to understand the logic behind the math. Getting this right is everything. First up, N. This is the future value. Think of N as the summit of the mountain you're climbing. It is the quantified version of your future aspiration. In our little thought experiment, it's that $50,000. It's the specific, defined target that the entire plan is built around. Next, we have I, the interest rate per period. This is the growth engine of your savings. But, and this is so important, a very common student mistake is failing to align this rate with the payment period. An annual rate must be converted for monthly or quarterly payments. If your investment earns 8% annually, but you're making monthly payments, you cannot just plug in 0.08. You have to divide that by 12. Getting that small detail wrong will throw your entire calculation off, sometimes by thousands of dollars. And finally, N, the number of periods. This represents the total number of payments you're going to make. Now, the crucial point about N is that its effect is exponential. Notice where it is in the formula. It's an exponent. That means increasing the number of periods, even by a little bit, can have a dramatic impact on your outcome. This is why financial advisors always say to start saving early. Time, which is represented by N, is your most powerful ally. All right, let's move to our case study. Let's see how this builds into a practical application for a personal retirement goal. We're going to see how the theory translates directly into a tangible plan. Okay, so we'll use the scenario from our source material. A person wants to accumulate $50,000 in 20 years, and they found an investment that they believe will provide an 8% annual interest rate. Our job is to find R, the regular payment amount. So we will now meticulously apply our formula, breaking the calculation down into 4 clear steps to ensure accuracy. First, we tackle the denominator. We calculate the growth factor. 1 plus our interest rate of 0.08, raised to the power of 20 for our 20 years. Step 2, we isolate the interest portion by subtracting 1 from that result. Step 3, we calculate the numerator, $50,000 times 0.08. And finally, step 4, we divide the numerator by the denominator to find our answer, R. And this brilliantly illustrates the result. To reach $50,000 under these exact conditions, the required annual payment is approximately $1,092.60. See what we did there? We took a big abstract goal and used this formula to turn it into a concrete, achievable, yearly action. That's the power of this. But this isn't just for personal savings.
Let's pivot and see how this exact same logic is absolutely critical in high-stakes corporate finance. The numbers are bigger, the stakes are higher, but the underlying mathematical principle, it's identical. Businesses rely on annuity calculations for everything. I mean, how do you think a company ensures its employee pension plan is fully funded decades from now? Or how do they budget for a massive capital expenditure, like a new factory 10 years down the road? They use annuities. They create sinking funds to retire debt methodically. It's all about turning huge future liabilities into manageable, present-day financial commitments.
Right. Imagine you're the CFO of a major corporation. Your company has a $10 million bond issue that matures in 15 years. You have a fiduciary duty to your shareholders to be ready for that. You can't just hope the money will be there. So you turn to your finance team and say, our bond issue matures in 15 years. We must use the sinking fund formula to determine the quarterly payments needed to ensure we can meet that $10 million liability without disrupting our operations. You see, the principle is the same, but the stakes are millions of dollars. You're turning a future liability into manageable, present-day action. So the takeaway today is this. The annuity formula isn't just math. It is a framework for discipline and for planning. It's a tool that empowers you, whether you're an individual or a corporation, to build the future you envision. It transforms large, intimidating goals into a series of small, achievable steps. So the question I leave you with is, now that you have the tool, what future will you plan for?